Picking back up with our lesson on logarithms, here we are in 5.4. We're going to graph the log of base 3 of x. Here's a little hint. Find out where the argument, the inside, could equal 0. I think it's pretty evident here. You'd say x would equal 0 there. That's definitely a place where you're undefined. That's where your vertical asymptote will be located. The vertical asymptote is not a number, it's a line, and you have to write that equation of the line. Now from here, my suggestion is to make the log circle. You get 3 to the y equals x, and we're going to make ourselves a quick table. But what we've been talking about is that the graph of a logarithm is actually the inverse of an exponential curve. So normally you're plugging in x values into a nice simple table. This time we're going to plug in y's. Remember, x and y are switched, so this would facilitate, this would make your graph real simple to find. If you let y equal 1, 3 to the 1 is 3. Plug in a 0, 3 to the 0 is 1. Plug in a negative 1, 3 to the negative 1 is actually 1/3. Now from here, I'm going to go ahead and I'm going to make my graph. And we know already that x equals 0, put that dotted line in there as an asymptote. Even if it's on the x-axis, you want to, on the y-axis I should say, you want to have that. But look, you'll have 3 comma 1, that's this point right here. 1 comma 0 is right over here. 1/3 comma negative 1 would be, roughly about right there. And hopefully you can see we're going to be getting closer and closer. This looks very much like the graph that we just had right here. This would be a super fast way to make a graph of a log curve. Take a look at part B. What we're going to do from the beginning, from the very get-go, is ask ourselves, where would that inside part be equal to 0? You could set it equal to 0 and solve. That's where you're going to find your vertical asymptote. It's x equals 1. And rest assured, you could, even right now, quickly begin to graph that and to put it in as a dotted line, of course. That's a good thing to do. From here, I'm going to switch this around. We'll have log base 4 of x minus 1 is equal to y. Let's do a log circle. So we'll have 4 raised up to the y power is equal to x minus 1. And in fact, if you'd like to solve for x, you could very quickly just add a 1. But hopefully you get the idea. We're going to do pretty much the same thing that we were doing on that last problem. We're going to more or less plug in friendly values for y. Like y equals 1. You'd get 4 to the 1 here, which is 4. 4 plus 1. You'd get a 5. A plug in is 0. 4 to the 0 is actually 1. 1 plus 1 is a 2. Plug in a negative 1. 4 to the negative 1 power is 1/4. 1/4 plus 1, you'd get 1 1/4, or 1.25. Well, where are we going with this? We'll have a point at 5 comma 1. We'll have a point at 2 comma 0. And here's about 1 1/4. That's going to be down here at negative 1. You can get this thing graphed out in a hurry. And that's maybe the nicest, quickest, easiest way to get the graph of a log done. Wrapping up this lesson, the log circle will help you solve as well. We could very quickly say here's 3 to the second equals 4x minus 7. In other words, 9 equals 4x minus 7. Add a 7 and you'd get 9 plus 7 is 16. Divide by your 4 and you'll have x is equal to 4. Come over here and do your log circle. You'll get x squared is equal to 64. And you probably want to solve by taking square roots. You'd say plus or minus 8. But bases cannot be negative. Bases cannot be a 1 either. You can only have a positive answer of x equals 8. Finally, for part C, this very well might be the strangest looking problem of all. You can say there isn't even a logarithm here. The question is, maybe we could rewrite the problem in that regard. Remember, the base of the log is equal to the base of the exponent, so I'd need to have log base e. The power is never inside the log. It actually is set equal, or it is the log. And then we'd have our missing component of 5 here. Do a little log circle, though, to check. You can see we have e to the 2x is equal to 5. But like we said on our earlier video, log base e is really natural log, ln. And then solving, I'll just divide by 2. Of course, I could get a decimal approximation on the calculator. It's super important to let you know this answer, though, is good. That's it. One little thing, I guess we're going to be going actually up to just 107, I believe, every other odd. Good luck.